I think we are reaching a level of intelligence where this kind of agentic behavior will start to increase more and more. It's already the case. And for that, you need a model that is able to format a structured output, to reason, to write a plan, to evaluate step by step, refine its own output.
Thomas Scialom, it's great to have you on the show.
Thanks for having me, and nice to see you.
You are a senior staff research scientist on LLMs at Meta's AI organization. You've been integral to the training of the Llama models, arguably one of the most widely used and best open source LLMs today. Maybe to set the stage and start off our chat, how has it been like being at the center of such an important moment in AI today?
Right. Look, it's weird. Maybe a quick anecdote I can tell you is I'm based in Paris, where it's very AI high, but less than in San Francisco. And when I went with my wife in San Francisco like a few months ago, she was like, we met people in the street or like, oh, you're the guy from Llama. And she realized it's something.
Yeah.
And like here, all my friends are, oh, you're working on AI. Cool. Like, do you do data science?
Yeah. And yeah, in San Francisco, people were stopping you on the street. So yeah, I think, I recently saw a video of Sam Altman with paparazzis behind him. It's a pretty interesting moment in AI today. So you just unveiled Llama 405B, which is an incredible milestone in open source AI. Maybe you walk us through Llama 405B in a bit more depth, which I think is the biggest open source LLM out there. What makes it unique to other open source LLMs?
Well, the size, of course, but beyond that, and that just one scaling dimension, is the scale. We train it on, again, like 15 trillion tokens. With respect to the preview release we did at the time, we have done much more post-training, RLHF, so the alignment is also much better. And so the resulting performance follows. Let's see the results on the Arena leaderboard, for instance, and other benchmarks. But I'm hopeful that it will be the best performing model out for open source. It has long context. It has, although we may not release it, like multimodal and other like capabilities. So it's really filling the gap with the frontier models.
And, we're definitely going to talk about deep dive into the training of Llama 405B and also all of these models. But maybe when when we're speaking about training of these models, right, this is quite a technical challenge when thinking about the scale of Llama 405B. Maybe before we talk about Llama 405B, just general training these large language models, what are some of the biggest challenges in developing these models and how do you navigate these challenges?
The biggest challenge to me is how to balance exploration and exploitation. And let me elaborate. Like, when you do some experiments, you cannot do that at the 405B on 15 trend tokens and do like 20 ablations. That's just not possible. That's the kind of run, even for smaller size, to be honest, like 70, that you put a lot of resources of this one. And so you need to be confident with the hyperparameters, with the data, the training mix, everything. And so how to choose that, you need to do smaller scale experiments. And to then infer the right parameters at a larger scale, you need to infer the right data mix. Maybe like a simple example. What is the impact of multiple epoch, so repeating the same data multiple times at a larger scale? There's more weight, so the model memorizes more. And so you could have some new phenomenon that you didn't observe at a smaller scale. And how to trade off this unoptimal large-scale run, because we just couldn't grid search everything, versus the exploration you want to do at a smaller scale is something tricky. And so how even to balance the resources between exploration and exploitation is very challenging.
Okay, and maybe walk us through some of the best practices that you guys have developed while balancing while having that balancing act between exploitation and exploration, what would be your advice for, the small handful of other teams looking to train large language models?
I think in general, the best advice is to follow first principle. Like, okay, garbage in, garbage out, for instance, for the data. And data is probably one of the most important thing. So making sure that the data you collect is high quality, reviewing it manually with some processes, with quality analysis, some classifiers. We use Llama3 to do that and select the tokens for pre-training. And making sure like you validate your ideas and your intuition with a run at a smaller scale and you see the improvement. It's never guaranteed, but it's likely to lead to some gains at a larger scale. And I would say at every stage of the pipeline, being very, very rigorous and meticulous to get the best effort, to have the best class pipeline.
Okay, that's great. And you mentioned here the data and making sure that the data is high quality and doing qualitative analysis. I'd love to learn a bit more about that because, massive amount of data is going into training these models. How do you make sure that this data is set up in a way that you're able to ingest it into these models and have confidence in the output? So I'd love to see kind of what are the processes that you adopt to make sure that the data is high quality, because that's a big aspect of making sure that the model is successful in the long run.
For pre-training in particular, I don't know if you want me later to deep dive more in post-training and RLHF, but for pre-training, you just collect basically web tokens. Let's say you have like famous data sets like Common Crawl or the Pi. But the truth is that the web is garbage. It's just random. If you look at a random paragraph or document from this data set, it's random noise. And clearly there's something wrong to train your model on 50% random noise. Like it's a waste of compute. So the first basic thing to do is, can you train a classifier or using some heuristic or machine learning models to select what is the right token? Then can you do some topic classification? Maybe you can rebalance your data mixture such that it covers not like 0.5% some domains, but it's more like balance. You don't have like a hole in your racket in the knowledge. Then can you add additional sources? What is your pipeline to clean the data? Like if you convert, for instance, we developed Nougat last year that performs a scientific OCR. Just putting a lot of effort in this model so that you end with a high quality text from a PDF on scientific text leads to improvement on reasoning, for instance.
Okay, that's really great. And this here, we're talking about the pre-training aspect of it, but you mentioned as well, there's a lot of work that happens on post-training and reinforcement learning from human feedback. So I'd love to learn as well about that aspect of training a model and what that looks like in practice.
Maybe the first interesting thing to say is, overall, the general stage for people is you do supervised fine-tuning so that you start from your pre-trained model, which is just the next token prediction, finishing sentences. And you align it to follow instructions in the chat model style. Through for supervised fine-tuning, in general, it's like what human will have written as the expected answer from a chat model. And then you do reinforcement learning with human feedback. An interesting thing to note here is we stated that in Llama2, generation from the model itself with through reinforcement learning feedback, synthetic data, are higher quality than human written outputs for a lot of things. So if you follow this principle, on what should we initiate Llama3 model with supervised fine-tuning data? We could ask humans or take what we did for Llama2 and take the supervised fine-tuning data we used. But this is actually worse than what Llama2 generated. So we use Llama2 to generate the first pass, the first round of supervised fine-tuning data. So from the round one, and we had multiple rounds of RLHF, we use Llama2 to initiate with synthetic data. And once you have that, you have a Llama3, supervisedly fine-tuned on Llama 2 outputs, prompt and outputs. And then you start your RLHF rounds. You collect new preferences with this model. You train your reward model with Llama3. You sample with your Llama3. You do reinforcement learning and so on.
That's fascinating. And essentially, you reach a point where you have kind of a self-sustaining loop of producing data because you're improving the model, which creates supervised fine-tuning data, which improves the model, at what point do you reach a limit in improvement in that phase?
So we have so many open research questions on RLHF, and this is one of them. We haven't seen plateau really yet, but we are also in a process where we try to nudge the annotators to always ask harder and harder prompts at the edge of the model capability. In a way that, well, write a poem about a language model is something that now the model does pretty well. So we will ask annotators to ask less about that and more about something more complex, but not too complex because, again, the process of annotation here is that you ask a prompt, you sample 2 answers from your model, and you ask the annotator which one he prefers. And so if the 2 answers are bad, you don't have any signal, basically. So you need to always be at the edge. Maybe one difference with Llama 2 I can emphasize is the teacher mode we had, which is basically if the 2 answers are bad, we can sometimes, not always, enter in what we call the teacher mode, where the annotator can basically write a critic prompt saying, oh, this answer, even if I preferred it to the other one, it's pretty bad for this and this reasons. And then edit the answer to make it better.
And that creates that's an additional way to retrain the model with
exactly.
human.
And to move away, to have a shortcut when the model is just bad.
Okay, that's very fascinating. And so that's one of the open questions is that has yet to plateau, right? And I think this is a great segue to discuss, the broader generative AI landscape as well, because there's quite a few open questions on LLMs today and what the next generation of LLMs will look like. From the outside looking in, you definitely have a lot more insight than I do. The leap in intelligence from models seems to be getting smaller with each release. Or, for example, the jump from GPT-2 to GPT-3, the GPT-3 to GPT 3.5, 3.5 to 4, seems to be getting slightly smaller with each iteration. So one, I'd love to see if you think that is correct. And then second, do you anticipate another significant leap in intelligence soon? If so, what does that look like and what's driving it? So yeah, I'll pause here and let you react.
If we think in terms of order of magnitude, so first thing is, and I elaborate on that soon, yes, I anticipate much bigger jump than what we had. I think it's easy to measure the gap of intelligence between our knowledge, not intelligence, let me say, knowledge between a 5-year-old kid and an 18-year-old kid, rather than an 18-year-old kid and a 30-year-old.
Yeah, that's true. Yeah.
I think we are seeing kind of the same thing with those models memorizing massive amount of knowledge, and at some point, they know almost everything. And so, yeah, maybe the gap starts to be smaller and smaller in terms of knowledge, maybe beyond the long tail, but it's harder to measure. And so the perception from people is that the gap is smaller. I would argue that in terms of intelligence, reasoning, it might not be true. There's all those tasks on, for instance, on math, the benchmark. We had seen immense progress from GPT-2 to GPT-3, 4, and now Gemini, that's reached
Claude 3.5,
and almost 90, I think, with one of their recent models. That indicates some progress. I will also argue that at some point, what matters is not the knowledge. It's fine to not know something if you know how to find it by browsing or by looking at internet, right? And so I think we are reaching a level of intelligence where this kind of agentic behavior will start to increase more and more. It's already the case. And for that, you need a model that is able to format a structured output, to reason, to write a plan, to evaluate step by step, refine its own output. Ultimately, I think it's one of the key features, self-critique itself. Right now on the RLHF stage, everything is synthetic. Yet we have a human at some point that says this output is better than this output. And we may see, to me, the early sign that the model is able to judge. In some contexts, it's still limited. And while we will not see this kind of skills improve on some the main benchmarks, which are very knowledge intensive anyway, like now, maybe the gap of improvement on this kind of new skills and abilities will increase, which to me let me think that the gap is just not narrowing at each generation. Now, the second thing is, when you achieve this level of intelligence, you can compound with some additional order of magnitudes improvement, like tool use. We did tool former like 1 year ago. And now with instructed model in the zero shot, you can give a tool and the documentation in natural language to an API, and then they will learn to leverage that. And what I was saying before, learn to search online information, for instance, if it doesn't know. A calculator, code execution, and all those tools, multiple steps and self-refinement, and say, oh, now like it's a dead end. Can I maybe explore another way to solve that? And all that will compound to an orders of magnitude more intelligent behaviors and capabilities that may not be reflected with the pure LLM performance on some benchmark, but with new generation enabling that.
That's a really great insight. And yeah, I couldn't agree more. I think the agentic, path as well will definitely drive a lot more usefulness, even if, on the LLM benchmark, you may not see that come out very directly. But maybe to expand on that, how much of that agentic workflow is enabled by, like software engineering, with, like having LLMs with like a layer of tools access and making sure that there's kind of a recursive nature to like using the tools and all of that, kind of engineering work, versus the training of the model. So how do you kind of balance those, like to create a really strong agent? Like you need both, but how strong, like where are we now in intelligence essentially to enable these set of agent use cases?
So we created a benchmark last year called General AI Assistant benchmark, Gaia. It was interesting because GPT-4 had like 5%, GPT 3.5, 0%. It corresponds to like tasks that will require a lot of different steps. So complex tasks for which the models are failing, for which the answer is not present on the internet. An example I can give you is, for instance, like the NASA published a photo at some point on Twitter about this astronaut, and they published a similar photo but with another one in the same condition a few months later. Can you tell me the number of days between the two? And you know that this information is not present on internet, arguably, so there's no memorization possible. So the model has to do the steps. This is a kind of question that doesn't require any expert skills. We didn't want to go to SWE agent or things like that. But that's what any human will solve easily, given enough time, but that models are totally failing. And with the last year, what we have seen is some agentic framework like AutoGen, OS Copilot, Hugging Face Agent, that what you mentioned, connecting tools and some like self-refinement loop and things like that. And this was critical. It moved performance from like 10% with GPT-4 to now something like 30%. It's yet to be solved, but the progress is immense. It's tremendous. That being said, if you power those agents with GPT-4, that's the performance you get. If you power them with GPT 3.5, the performance is 0. That said, that actually the gap between the two is crazy in terms of capabilities.
Agentic capabilities, okay. And yeah, you can imagine that, GPT-5 or, Llama3 403B, right? Like will drive a lot, 405B, sorry, will drive a lot of the progress there.
No, that's true. And we put a lot of effort. We emphasize that, I think, in the paper about the tool used for post-training. I think Llama3 is very good at zero-shot function coding, which is a key feature that so many people ask about. So I recommend to test it for that.
Definitely the community is gonna, play play a lot with Llama 405B and the Llama 3 family. So maybe one additional thing on the state of generative AI. Do you believe that scaling laws will continue to enhance performance of models as we just, increase size of data and, the training runs and the compute? With this famous Twitter image of, small circle GPT-4, massive circle GPT-5, right? And it will have 1000x performance. At this point became a meme. But do you see that growing, like that scaling laws continuing on as we see today, or are we reaching a plateau?
Yes and no. I think it's a bit more nuanced. I think that absolutely. Scaling will lead to improvement, yes. That being said, what do you want to scale? And by that, there's so many improvements in terms of algorithms, in terms of training recipe, that leads to a better scaling slope. That 2D model at 7B are often better than what we had like 2 years ago, or like than GPT 3.5, which was much bigger, or things like that. So I think like Mistral just released a 7B model that is outperforming Minerva, which was something based on, if I'm correct, 300 billion, I forget parameters, so 50 times bigger. And so there's so many improvements that comes from algorithmic optimization as well, from data quality, from the training method, and from additional external things like tool use, things like that could end in a better like loop with synthetic data, which are augmented in an expert iteration method. Like that. But yes, scaling is a way, but not scaling anything. Like if we had to scale LSTM, we will be nowhere today. So yes, scaling will keep playing the biggest factor role, but we can, if we scale by 1, 2, 3 order of magnitudes, we can get maybe 10 or 20 order of magnitude scaling by improving all the other aspects.
That's great. So quality of data, algorithmic optimization, are also big levers outside of just like additional data and like compute. One thing that we saw as well kind of this year, especially with GPT-4o, was like multimodal capabilities, right? Definitely multimodal capabilities improve a model's usefulness, but how crucial is it to train models on these different types of data to boost, raw capabilities, right? Maybe intelligence is not the best word, but like their ability to perform tasks. Like, so yeah, walk me through it, like the importance of having different types of data to have more performant models.
First thing is you want your model to be able to process ideally any input to any output, and that's like just much more like smoother, scalable than like a very complex orchestration. That being said, with respect to how it will improve a multimodal transfer to like, let's say, text, is a bit unclear. Not that it doesn't exist. My intuition is that either we didn't crack the problem yet, or another hypothesis is that text is so dense in information signal from what it contains. It's the log of the thoughts somehow, that you need so many more images to basically map the signal of information you will have in the text. What else? Maybe in multilinguality, there's an argument that speech end-to-end model, may with the accents, intonations like that, leads to improvement. There's a fair hypothesis there, which we haven't explored yet on our side.
And then maybe one last question on the kind of the state of generative AI and like the technical landscape that we're living in, that we are in today. You mentioned something, if you scaled LSTMs, we wouldn't be where we are today, right? Gary Marcus famously repeats this notion that deep learning is hitting a wall and that, LLMs and generative AI will plateau as time goes by. He's been saying this for the past at least 5 years, and we've been, seeing improvements all throughout. Do you think deep learning and the transformer paradigms are reaching their limits?
No. I mean, anyone that said that in the past has been proven wrong in a very short term.
Yeah.
No, what I can tell you is, look, what I often say is, one, we know that we have, I was saying before, exploration with respect to exploitation. I think if we had like zero more progress, zero more breakthrough in the next decade, we will have still like 5 to 10 years to just explore, understand all these breakthroughs and revolution we just had in, which will lead to incremental significant progress, but incremental only for the next 10 years. Integrating all the modalities together, managing everything, agentic behaviors, well done, inference, quantization, better post-training, where we are still like at the prehistorical age there. Like all those things together will lead to actually probably few orders of magnitude better models. And yet there's like so many resources put in there, not just money, but people that are working on that, and more every day. It's likely that what the last decade of deep learning told us, that a breakthrough will come again. What it will be, I don't know. We had seen like a post-training RLHF method, we had seen transformers, we had seen self-supervision, and all those things progressively. It's likely that something else will happen and will again give us like few orders of magnitude more better deep learning stuff. So I think it will be very crazy to bet against that.
I personally agree with you. We should have Gary Marcus on the show, see his thoughts. Maybe as we shift a bit to discuss kind of, the broader LLM landscape as well, and, other providers, the open source community, the private foundation models, with the announcement of GPT-4o by OpenAI, Claude 3.5 by Anthropic. First, I'd love to see from your perspective, how do you view these models, right? Like, from a technical perspective, what is impressive about these models? And then what are your thoughts on their capabilities? And then I'd love to see kind of how you view the ecosystems of open source AI versus, closed source or, private foundation models, emerging or like evolving over the next year.
I think all those models are pretty good. I guess we're at a stage where we are more or less at the same level of capabilities. Besides maybe GPT-4o being like end-to-end multimodal, which is something kind of breakthrough compared to the others. That being said, like progress will keep going at least incrementally, and then for the next generation of compute and scale, I'm really keen to see what will happen. I would say we have filled the gap between open source and closed source. Think about 1 year ago, we were releasing Llama 2. I think it was a few days, about 1 year ago. Before that, you had zero open source chat model. We had done a long way. We have come from a long way. Now there's more and more open source models that are better and better. Hopefully with this one, we'll fill the gap even closer. Now the question is how to have open source being number one and not just number two, which we're working hard on that. The trend is pretty good. I guess the question, which is an open question to me, is in a world where there's more and more companies still like leading the space, but with some secrets source like Gemini, Anthropic, OpenAI, will it mean for them that they cannot compete with the open source community? Because every time there's a new thing that they will work on, the open source community will fill the gap and will be able to get better and better models. And like closed source is not the way for open science, and will just limit progress. Or they will be able to make some breakthrough internally that will be very hard to reproduce externally, which leading to some very important advance for some of them and not others. There's an open question there. We'll do our best so that open source leads the game.
Okay. And, this really segues really well to my next question because, I think Meta is the exception here in a lot of ways and a few other organizations, such as Mistral maybe. But do you believe like private models have an inherent advantage over open source counterparts because of their compute, the amount of money they have, like their ability to hire researchers, the data that they're procuring? If so, how can you mitigate this as a community, as an ecosystem, rather than, as meta?
Yeah, that's a question I often ask myself. I don't know to what extent. I mean, for instance, we don't train our model on user data. We don't have like anything special about that besides working hard on high quality data. So we don't have a competitive advantage to be at Meta right now for that kind of models. Do they have at Google or at OpenAI? Maybe. I don't know. Is it something? I'm not sure entirely. It may be helpful, but to what extent is not totally clear to me yet. So I would say the main thing is, OpenAI started that game and betting on scaling language model a long time ago. We had our first language models 1 year and a half ago. Like I was working on Galactica December. It was 1 year and a half. Then my friends in Paris followed with Llama 1 pre-trained model. And we are very, very early in the game on our side. So we move very fast, I think, to fill the gap. But the trend is good. I think it's the main reason.
And, the open source community is super vibrant, right? Llama has an incredible open source community. And there's a lot of players today in the open source community, right? Which LLM providers do you think will survive this wave, right? Or maybe like what will be the defining feature of an LLM provider that will survive this? I don't want to name names here, and why do some models gain popularity while others don't, right? This is such an interesting aspect of the ecosystem.
Yeah, that's interesting. I mean, I think first of all, the performance of the models is something that works. There's, of course, a bit of hype and marketing around that. Although most of the time, I tend to think that this is the credibility of the organization that reads the models. Like, it's not, you can release everything with putting all the numbers and overfitting benchmarks. If people know that and discover that once, they will have much more doubt the next release you will do. Like, for instance, we have proven in the past to be very solid in our evaluation like that with Llama. So people trust us, and others have done the same, and that's good. So I would say then what I'm seeing right now, but that might change, like things are changing very fast, is a lot of small models that are either specialized or good general AI. And you want to take this one for code, this one for like science, this one for math, this one for general stuff. And then for this bigger size, there's less and less competitors though. For 0.5, like at GPT-4 performance, we are the only one. There's a question of what is your usage. There's probably a lot of platform actually that will take advantage of that and serve all the models together. I think that's good. That's good for the community. That's good for transparency. It's good to not have a monopoly there. So overall, I'm in favor of having more and more open source companies raising data models.
Couldn't agree more. And then, because something they hinted at, I'd love to also unpack a bit more. There's going to be kind of a generation of really small models for really specific use cases, right? Like CodeStroll is a good example of that, for example, right? But there are also, massive models that you can use across a variety of use cases. How do you see that, aspect of the LLM ecosystem evolving? Like maybe when should you use a massive model versus a small specialized model? Like I'd love to kind of gain your thoughts on how you see the ecosystem evolving there.
I think it's always a question of price to pay and time to inference for your product needed and capability in the setup you need for your client. If you need something very, very good and you cannot accept any hallucination or like that, and the 405B model is giving you enough performance so that your product is useful for your client, but a smaller model is not reaching the threshold, well, you don't have choice. Then it's a balance with how much you are willing to pay. A 405B model will cost more than a smaller model. It will take also a bit longer to infer versus being better. So it's always case by case product question rather than anything else. Now there's smart strategies that I'm seeing more and more, leveraging good models at the beginning to create synthetic data that you will maybe distillate in smaller models, and that. So there's also all this stack that people are building.
Interesting. So a lot of it is depending on, inference time and costs for serving these models and, the use case, which definitely agree with you. And I think this segues as well to my next question, which is, you're in a research environment that's actually shipping models that are being used in products today, which I think is quite a, not necessarily common for all types of research environments, that it's a lot of the research that you produce is being used in production almost immediately as soon as it's shipped. So what's it like working in a research environment that's, also delivering, real world value as soon as the research is done, right? And how do you succeed in this type of environment?
Yeah, it's very new, and actually it's reflected with even our organization at Meta. We had, as you may know, split between, we were all working at FAIR, exactly,
Yeah.
the Foundation AI Model Research. And we split it in a small group at the beginning to a new org called GenAI, which is also responsible not just to create foundational models, and Llama2, Llama3, but also product, Meta AI, and all those things that are now shipped in our products. I think it's a right move, and it's very interesting because we are at a level of capability for those models where it's directly useful for some products. And so driving the research with the product feedback, what is useful or not, what do you need, where the model is bad, just that like evaluation of those models, which are general by nature, is extremely hard. Having some people actually using your model for direct products, having billions of users, telling you, your model is bad at that, and then telling you, yeah, I saw the progress, now it's good at that. This is extremely useful.
You mentioned something like serving a model to billions of users. That's, I think, a challenge that only a handful of teams on the planet have to deal with. How do you deal with such level of scale when serving? Like, what are some of the best practices, tricks you've learned along the way to be able to serve so many users with inference?
So I think one thing I can answer you technically is having super efficient small models, which is why we kind of from the scaling laws went way beyond what is optimal compute at training time to actually like be beyond the scaling, the chinchilla trap. I can elaborate if you want about that, but basically we train it on so many tokens that it makes small models very efficient. That's the first thing. Maybe a word about that. It's just scaling, you have two dimensions basically. The size of the model, the weight, or the training tokens, the number of steps. And thing is, at inference time, one of the two dimensions drops and not the other. Your model is big, it will remain big at inference time. But training number of tokens, of steps, is not a factor that impacts inference time. You can train on 1 billion token or 100 billion tokens, you will have the same inference time. And so we train them on a lot of tokens. That's one way first to tackle efficient models for inference, serving a lot of users. Now, the second thing I want to add is that's not my expert skill there. There's huge teams at Meta, and that's in our DNA to be able to scale. There's super good teams here I saw that are able to sell that, to start to work on that. And while we haven't served yet on billions of users, we are starting to see on Meta AI. I don't know if you tested it, but it's pretty good. We've already integrated generation of images, flash images, flash emu, and things like that. That's pretty cool.
Okay, that is definitely pretty cool. And then maybe as we cap off our chat, Thomas, what current research in the field excites you the most at the moment?
Agentic behavior. I think pre-training has still a lot to get, but it's getting more major. There's yet a lot of different things to get. Post-training, we are now starting to understanding the beginning, but there's a lot of research to improve it incrementally. But agents is to me what will lead to the next many orders of magnitude more capabilities. And it's the far west for now. So, when I did Toolformer, that's when I said to you before, I realized we need language models aligned to follow instruction to move to the next stage. And my view is now that we have GPT-4 level capabilities with Llama3, that's the level of capability where you start to see the preliminary self-refinement capabilities. There's this nice paper, Eureka, from Jim Fan, NVIDIA, for instance. And from now on, while we will keep increasing and improving on post-training and pre-training, this is where you can start to do agentic behaviors.
Okay, that is excellent. And then maybe as we wrap up, Thomas, what are some major trends that you expect this year to kind of, happen in the LLM space and the generative AI space? And maybe if we can, when do you think that next breakthrough will happen? Like, what's your time range for the next breakthrough, if you were to put money on it?
Right. So about trends, I would say end-to-end multimodal integration. That's starting to, we had the Moshi, the first model release. Actually, GPT-4.0 is not ready released in multimodal. So the startup Qt, I did the first release there. And I expect to see more and more. We will go there as well, of course. That's one. Two, agents, of course. We are seeing that more and more. Three, like compute optimal inference, a lot of strategy to improve compute. And actually, the fact that we released for the first time such a big, good model, I expect the community to play with it and to find a lot of crazy ways to make it more inference friendly. For, I would say, robotics, it's something very, very at the age at the beginning, but I expect to see more and more progress soon. Which is the same, it's very correlated to agentic behaviors, but I'm also seeing the cost of robots decrease, which will make these models grounded in real physical work, basically.
Yeah.
To answer your question about the when is the next breakthrough, I don't come from the future. I don't know. I would say something big will happen in the next 5 years, or I'll be surprised.
Okay. So that's the only prediction I was asking for. Next 5 years, something big will happen. We'll see what it will be.
And I don't know.
But I think
I have no clue.
we don't. We don't know what it is. And thank you so much, Thomas. I think that's a great to cap off today's episode. Thank you so much, Thomas, for coming on DataFramed. I really, really appreciated the chat, and thank you so much for coming and sharing all the great things the Llama team is working on.
Thank you for having me.